All right, if we can get situated, we can begin. Thank you, everybody. Welcome. This is the last breakout of the afternoon before we go back to the general assembly area to go through. Today we have Till Westmann, our Senior Director of Analytics, to talk to us about NoETL for SQL. And this is really going to help us to establish those real-time analytics with Couchbase. And this is really making sure that operational data that we've been storing and working with, let's get some more value out of that data beyond the actual data, the actual collection of that data itself. So Till, I'll send it over to you. Have a great day.
Thank you very much. All right, can you hear me? Yes, okay, it seems the mic is on. So actually, Art, it's NoETL for NoSQL. Not NoETL for SQL, so they can't get around that, but we can, I think. All right. As Art already mentioned, right? I mean, it's kind of two-tiered here. It's mostly about the analytics service and about the NoETL. That's kind of a feature here. So the way we're going through this. So first, we'll talk a little bit about, what it is, how that fits into the Couchbase universe. Then I'll show a little bit about how you can use it. Then give you some more insights after you've seen how you use it and how easy it is and how much you would love to use it. And then basically I'll tell you how to get it. So you probably listened to the keynote this morning, and so there was a discussion kind of about Couchbase being the engagement database and being the database that captures all the interactions that you have. That basically, and you heard about the fact that the interaction to transaction ratio is pretty high, right? I mean, the look to book ratio. And so we have, that is kind of the model in which we're living. And we also have an analytical database in this model. And that is, of course, there to analyze your data and especially also your interaction data, right? I mean, the reason why you capture the interaction is usually because you want to find out something about the interaction. And so, so what we are doing, and so we'll introduce the Couchbase Analytics service, which is doing some more of the analysis, and so it will kind of increase the overlap between the engagement and the analytical database that we have on the slide. And so of course, analytics is a huge space, and we're not doing all of that space, and so I'll talk in more detail about kind of what part of that space we're looking to work in. But before I come to that, I would like to just basically start off by looking at what more traditional solutions do. So if I have an image of how that usually works, so you start off, you have a business application. In your business application, you probably have some objects or some records, and you work with them, and that's the operations data. That operations data goes into your operational database. That's where it's stored. That's where it powers your application. And then if you want to analyze that data, what's usually happening is, so you have an ETL process, you have an extract, transact, load process. You take that operational data out of your operational database. You transform it into a shape that is better suited, that basically is optimized for your analyses. Then you bring that into an analytical database, which is usually a batch process. Your data looks quite different after that, because before that, in your operational database, or actually in your application, it was probably nested objects. In your operational database, we're not exactly sure what it was. And usually when you go to the after the ETL, it's all flat tables. And then you take that analytical database and you work with the analytics tool. And that might be batch or might not be batch. That depends kind of on the tool that you're using. So the way we want to change that is, the way we're changing that actually, is that we don't have this separation. Instead of basically using different systems for the transactional or for the operational and the analytical database, we are adding a new capability to the Couchbase Data Platform. And we're adding a new node type to our multidimensional scaling, which is the analytics node. So what you will do now is, instead of going from your operations data to your ops data, that's kind of the same step, then you will basically be able to analyze your data in the form or shape that you have it in your application and use that for your analysis. So what's happening, you save basically all of the different translations here. What you also gain is that in terms of the agility and flexibility that you get for development, that you kind of maintain the agility that you had when you went to NoSQL. You went to NoSQL probably because you wanted to be able to add fields flexibly, to basically not have to have a schema change for every time you add a new field to your application. And so this basically is something we want to transport over to the analytical side as well. Am I still on the line? Okay, good. Sorry. So we are basically allowing you with this service to analyze your data in the form or shape that it is in your application. And if you change the data that's coming in because you add new data, it also goes directly into your analytical system and it's part of your analyses. So instead of doing what you have in the traditional model where whenever you add a field to your operational data and then it goes to your ETL process, right? And then you get the ETL schema meeting that happens every 3 months to find out the new schema that you now support for getting to your analytical data, right? All of this transaction, all of this huge organizational process is basically gone because that data just flows, continues flowing and is part of your analyses. All right. Yeah, so that's kind of, does that make sense from that perspective? Nodding, no. Okay, everybody's nodding. Okay, I think we're still good. All right. Okay, so let me quickly, so after that, I hope that made sense. I'll give you a very short kind of technical overview what it actually, so what Couchbase Analytics actually is. So technically speaking, Couchbase Analytics are two things that we're building here. The first thing is that we shadow our data for processing. What does that mean? So right now, if you know Couchbase, you know you have your data in your data nodes. Your data nodes are usually replicated using DCP, right? It's a high-performance replication protocol. I think Wenka talked about it. It was the protocol that basically was anybody here in the last session? Okay, good. So that's the same protocol. And so what we do is we take that same protocol and use that protocol as to kind of create another replica of the data, which we call a shadow, which is a single shadow, which basically is very fresh, right? It's as fresh as our replicas are. And that basically is what you get for your data. And all of that processing works in parallel, streaming, right? So basically you have a very low latency for the transfer, and you also have a very low load based on that. So basically it doesn't cause any load on your transactional system. I mean, this replication protocol is running, right? And you get the data and you bring it in here. And so then basically what you do, you have the shadow of the data. And on this shadow, you now basically can run your analytical queries. And what we have a full MPP query processor, full massively parallel partition parallel query processor on that basically works like, yeah, basically if you see it historically, it's kind of in kind of a similar architecture as Teradata has. Basically, it's completely partition parallel, but of course, it is built for NoSQL. It's built for JSON data, for semi-structured data. So it basically inherits the nice operational properties of these databases or of these query processors, but not the rigidity that we're trying to avoid here. And the other thing that you're gaining here, which is very nice, is that by basically separating this ingestion from this query processing, that you also get the workload isolation that you would like to have between your operational and your analytical processing, right? That also, usually in your operational systems, you have exactly that. You have one operational database, and you clearly don't want that be impacted by the analytical queries. That's why you build a data warehouse in the past and next to your operational database. And so by doing those two things, basically the goal that we want to achieve by getting this fast shadowing and this parallel query architecture, we want to achieve real-time insights for our business teams. That is the high-end goal, that you basically, with this very fast replication and the really quick query processing in your parallel processor, you'll be able to achieve that, and achieve that always on current data. If that changes, if the schema changes, the structure of your objects changes, it's always there. All right, so what are we getting if we have Couchbase Analytics, Couchbase Data Platform with analytics? So the one thing we're gaining here are ad hoc queries that allow you to ask anything. So that is one of the goals that you have. It's especially interesting in a schemaless context because, if you want to know exactly and you want to analyze your data, you want to find out what's in your data. Often, if you have a schema, you first look at the schema, you find out what it is. If you're schemaless, that's a little harder. So you want to find out what's in your data. And to do that, basically, you need two things. You need to have your current data, and you need to have the ability to run really any query you want. And any query you want can be limited by two things. It can be limited by the way you can express queries, right, by your query language, in which case we have a complete query language that is orthogonal, composable, and everything. And it is limited by the way you can manage your data. And since we have this parallel processing, we're able to do that. And we're even, if you don't have an index, if you don't have nothing, if in doubt, you can parallelly scan the data to actually be able to ask that question. The other thing that we're getting is, I just talked about, is the workload isolation. Additionally, we get independent scaling of those different operations. We talked about the multidimensional scaling, I think, today also in the keynote. And again, here, these are two different services. There's the analytics service that can scale, the data service, so that's independent. You also gain, what's very interesting, is a common programming and data model. So the data model and the programming model for both your application, right? I mean, your application objects stay the same. Your interfaces to your objects. I mean, if you go to the objects through one of the ways that you can get to the data, if you go through them through your KV, through queries, through analytics, it's all the same interface, right? Basically, if you write an application using those different services, you don't have to kind of have different skill sets in your team. It's all the same. And of course, you also get the unified management that you get from being part of the Couchbase Data Platform with all the properties that that gives you. And of course, the fast data synchronization that we had at the end. All right. So did it make sense? Are there questions on that? Oh, I'm supposed to have questions at the end, right? Okay. So let's look at how to use this. And I thought I would like to just show you how that works. Sorry about that. Okay, here we go. So we said, okay, so what we said is we talked about NoETL, and I want to show you a little bit about NoETL. So I have set up a little Couchbase cluster here. Sorry, the logging in. All right. Maybe that's a little bit too big. So right now it's a regular Couchbase cluster. It has 2 data nodes, 2 index nodes, 2 query nodes, and it has a single bucket in here, right? And so this, actually, two buckets in here. Those are two sample buckets. They're not very big, right? I mean, this is not. We will not show you anything about the scalability of the system right now. This is about the usability. And so if I have a cluster like this, I will add another node. So basically, I have another node, which is fresh node, just freshly installed. I will use this node. One sec. I need to remember this URL quickly. So this is a fresh node. And now I will configure this node, and I will basically tell it here which services I'm supporting, and I will remove the data, the index, the search, the current event, and I will just make this an analytics node. And I will join the cluster with this configuration. All right. Tasks build memory. I don't need a lot. All right. So now I have this cluster, and I go back to my servers. Okay, now I have this new node added to the cluster, right? It's an analytics node, as you can see. And it's not fully there yet. So in Couchbase, what you do rebalance. Okay, now the analytics node is part of the cluster. Okay, and now as it's part of the cluster, I will go to my analytics workbench. And okay, so sorry about that. Okay, so now basically I have my beer sample bucket in the data node. I've added this node to the cluster. Now what I can do is I will execute the statement. Can anybody read this, or is that too better like that? Okay, wonderful. So there's a statement that's create bucket. So what create bucket does, it's basically it's a statement on the analytics service, and what it will do is it will create a proxy for the bucket on the data node side, right? So this is basically a declaration of the existence of this bucket, right? And so I will do that. And so the next thing I want to do is, so now in this bucket, I have data of 2 different kinds. It's the beer sample. Maybe you know that. We'll look at it a little bit more later. It contains beers and breweries. And so what I will do is, from that bucket, I want to basically create 2 data sets. One that contains beers, and this is kind of the statement for that. I will be creating a data set on this bucket beer sample. And I will filter this by the type being beer, right? And so I can create that. Then I do the same for breweries, right? Again, I create another data set called breweries, again on the beer sample cluster, where the type is a brewery. Let me execute that. And the next thing is, so now basically I've set up the rules of engagement for the communication between the data and the analytics nodes. And now I will connect this bucket beer sample. And what's happening now is that now we create the DCP connection between the data nodes and the analytics nodes. And from now on, the data is streaming that way. So any new data, any new operations that come into the bucket will be shadowed to the analytics bucket and be available for the analysis, right? And so, let's just look at a few queries to kind of give you an idea of what that looks like. So the first thing I will do is I will just get one object from beers so that you can see what beers look like approximately. So beers, basically, okay, they have different fields. They have an alcohol by volume. They have a brewery ID. Then there's a description. There's a name. That's the 21A IPA and a style. So that's kind of what beer documents look like. Let's look what breweries look like. So again, here we have one object. It's a brewery. Basically, it has an address. It has a city, zip code, a country. So that's kind of what this looks like. It also has geolocation. Name, phone number. So those are kind of the two objects that we're dealing with in the queries that we'll see right now. All right, let's look at a very simple query. So, I mean, this is all not hugely surprising if you know SQL, and that's exactly the point, right? The point is to show you that these queries look like what you've done all the time before, and there's nothing scary about this. Here, basically, what we do is we get 3 beers with their breweries, right? So the query probably looks familiar. We are selecting the name as the brewer of the brewery and the beer name as the beer name. And then we do that from the breweries and the beers. We basically join them on the key that Couchbase uses to store the data. Then we order that and we limit 3 so that it kind of hopefully fits on the screen. Maybe, okay, right? That's all hugely unsurprising. You will see the kind of, it's the SQL as you know it. Let's go to something else that's a little bit more out of the ordinary. So what we do now is instead of getting that kind of, the last result was kind of still relational, right? It was a flat result. But of course, I mean, it's a query language for JSON. And so basically, we can, of course, query JSON. And we can look at JSON. We can ingest it from the bottom. But we also can produce it, right? I mean, it's a fully composable language. So therefore, the data model is complete JSON. And you can also produce that at the top. So in this case, what we want to do is instead of having kind of a long row of beers and breweries, we want to basically nest the breweries as an array inside of the beer. And we do that by producing a simple subquery in here, right? So we have a subquery in the select clause here, which will basically give me all the beers. It will join with the brewery on the beer ID and create these nested objects for that, and order the same by the brewery name. All right. Does that nesting in the query make sense? So the result, basically, what we're getting here is we're getting these beers, and inside of the beers, right, we have this list of the breweries. So it's an array of, sorry, that was the whole object that I collapsed, right? So we have 2 beers here, right? They have 2 brewers, right? They all have brewery name, and they have a list of the beers inside nested in here. So that's the non-first normal form that we support here in the JSON serialization. Okay, and that is basically arbitrarily composable. You can create subqueries that have nested objects and use them. All right, then, okay, so we said this thing is called analytics, so let's do at least something that does an aggregation. So that's a simple query that gets all breweries that produce more than 37 beers. So the number 37 is chosen so that it fits on the screen, the result. So it's, again, very usual, right? I mean, you have to select the brewery ID and the count from the beers and just group it.
Questions at the end as we go.
Yes, yes. Exactly. And yeah, so that is, again, right? I mean, something very, very common. So, okay, this will also, of course, return a result that will not surprise you. And then kind of putting this all together, we have a query that's slightly more interesting, which is exploring the beer characteristics by city. So we want to get the city, the number of beers in the city, and we also want to get the average percentage, the average, what's this? Average volume? What's ABV? Average by volume? I don't know. So, alcohol by volume. Yeah, let's see, I got it. So, we want to get the alcohol by volume from basically the beers and the breweries, and we want to get the name of the brewery. So, we find out which cities have the highest alcohol percentage in their beers, right? I mean, that's important, right? You want to find out where you want to travel, then if you're into strong beers, that's where you go. And so what we do is here, we join the beers and the breweries again, we group them by the city, we take every city that has at least one such brewery, and then order them by the beer strength. Okay, so again, so the point is, I think, if you're in the database world, if in the SQL world, you know all of this. So, and this sounds all very familiar, right? There's nothing scary in here. It's just a very nice and clean interface. I mean, we saw Ravi's keynote today in the comparison what you can have between kind of a system that has a declarative query language versus kind of their own invention of kind of having a structured way of describing query plans. Oops, sorry. All right. And so, okay. And now I will just basically do the inverse of what I did to break it down again, right? I will, disconnect the bucket, drop my data sets, and be done. So this was just basically to show you, if you think about what kind of the amount of ETL was that we did between kind of having the data and the data set and being able to analyze it, right? You saw we added a node to the cluster. We ran 3 statements, or 4 statements, right? And we were able to get going immediately, so without any more ado. And so that is kind of the kind of flexibility. I mean, if you're using NoSQL because you appreciate the agility and the flexibility in development, right? This is kind of how you want to do your analyses. All right. I'm going. Sorry. All right. Okay, we said no questions. Okay. So, okay. Now let's go to another step. So that's a very, very common question that gets asked. So you look at this and you see this, you know the Couchbase Data Platform, and you know, well, you know there's a query service, there's an analytics service. You just showed me all of these queries, you know. So what's happening there, right? I mean, you asked the question, so why are there 2 such services, right? They basically look very the same, and I also told you, oh, look, they have the same interface. Right? It's the same thing for the developer. You don't need to learn 2 different skills, so why do you want to do that? And so the point is, the difference is not necessarily not in the interface. It's in the use case that you're addressing, and that's have an example of such a use case. If you think about how you use the query and the analytics services, this is something from the hospitality business, right? I mean, if you have the query service is optimized for short-running queries. So what you do if you think about such an application and you have an online search and booking application, right? What you do is you get the details pages. You get the property and room details pages. You get cross-sell links, sell-up links, stars and likes, booking history. And basically, behind all of those things, basically, you have the query service to kind of power that application, right? On the other side, the analytics service is used for cases where, what you see here, right? I mean, you want to do some reporting. You want to have some trend analysis, right? Daily availability over a long period of time, cities with high room occupancy. So these are kind of the analytics or reporting characteristics, right? And of course, the difference between those kinds of questions is that they require different capabilities, right? And if you think about a little bit graphically, what that means, the queries that we had on the left side for the query service, those are queries where basically you have many, many queries, right? Every page needs a query, but every query touches very little data, right? Because it's very specific to a specific user. On the other side, if you are on the analytics side, you have basically much fewer queries, but all of those queries touch a lot of data. And that's kind of, and we need different architectures, right, to support that. And to kind of show that, I mean, we say we have different architectures and they have different behaviors, and so we wanted to find out, okay, so is that the truth? And so we did a little experiment here. And so the experiment is the following. So we have a query, right? Very similar to the ones we had before. It has, basically it is an imaginary social network. And it has, it's called Gleambook, and Gleambook has messages and users. And we want to find out who the chattiest users are. And so what we do is we'll get the user ID and the count of messages, right, for each of those users. And we basically take that from the messages that we join with the users on the author ID. And then basically we do something to the query to kind of get different shapes of the query. We filter, right, the messages that are used for this join based on this time interval, right? We have a time interval there, the two yellow dates. And this time interval can determine how many messages get into the join that you're running after that, right? And then we group by the user ID, and we order by the count. Okay, so you see the rest. And so we wanted to find out, okay, so if the size of this interval changes, right, how do our different services behave? And so we did that, and this is kind of where it's at. So if you look at it a little bit from left to right, so we basically have the interval for 1 minute, right, which in this example was about 10 objects, then 1 hour, which was 500 objects, then we have 1 day, which was 5,000 objects, 1 week, which was 25,000 objects, up to 6 months, which was 600,000 objects. That kind of qualified there, right? And what you see here is that you have, on the left side, right, it's pretty bad to have an analytics service, as you can see, because the query service just has very low latency, and that's all great and awesome. And on the right side, you're on the other end, right? And the reason for that is that the architectures of both services are very different, right? I mean, the query service, the NoSQL service, is really optimized for low latency, right? I mean, you basically do everything to kind of get to a single record quickly. You're basically trying to minimize the resource that you need to do that so that you can get a high concurrency, right? And that you can run this. Well, the analytics service goes the other route. The analytics service basically, it takes a query, right? And basically it plans it to be distributed on a large cluster of nodes. So you can have any arbitrary number of nodes, right? It usually scales linear with this performance with the number of nodes. And so you do a lot more work, right? You start up by saying, oh, let's look at that good query. Let's optimize that query. Let's produce a plan. Let's distribute it on the cluster. Let's run it. Let's come back. So on the left side, you see all of that cost, that fixed cost, right? That hurts you badly. But once you're actually in the mode that actually you need to deal with a lot of data in a potentially scanning way, then the parallelism that you use by having basically many nodes being able to contribute to that processing helps you a lot, and you get much better latency for such analytical queries. All right, next question. Of course, now where do you get it? And I think we did it 25 times today probably. The 5.5 beta is out. And this time around, analytics is a part of that beta. So we had previous developer previews. I don't know if you have been following us, maybe not. We had a number of developer previews that were kind of external to the actual platform, and now the current developer preview is part of the platform. Basically, if you download 5.5 beta or 5.5 GA later on, it's there, and you can use it to find out more what it does for you. Of course, you can get it at www.couchbase.com. You know, there's this on the download page. There's this gray bar there, and it says "Get it now," and that's kind of all you need to do to get it. To summarize, so what we're doing is we've extended the Couchbase Data Platform to power real-time analytics, right? As we talked about, we support ad hoc queries or other expensive analytical queries. It works in a workload-isolated way that you can scale independently to match your use cases. It has a common programming and data model between the services, and especially the data model between everything in the cluster. It provides unified management. You just saw when I did the demo, you just add one of those nodes. It shows up as one of those nodes. Your life as it has been before. And you get real-time data through DCP synchronization of your data. All right. Thank you.
All right. If we can open the floor up for questions. I saw a question up in the front when we first started. Do you still have the question?
I've been asking actually this kind of question yesterday on the yesterday's session.
Okay.
Still didn't quite get the exact answer.
Let's see if I can do better.
So let's say we're creating the data set called beers, right, as a select store from a beer sample where type equals beer, right? Will it be right to say that the space needed for the analytics of that data set will be the same or proportional to that portion of the original data set?
It will be proportional, yes. I mean,
Okay, so where I'm driving is that when I'm, let's say I have a huge database, right, and thinking about running some ad hoc queries, right?
Yeah.
Let's say I have 2 terabytes of data, right? How big should be the analytics nodes that I should be projecting there?
So right now in terms of data size, right, I would expect you to, I mean, depending on the setup, I would expect you have 1/3 approximately. So because what we've seen is that usually you have 3 replicas of your data, right, in your data nodes, right? That's for high availability.
Okay, well, I'm using 1, but yeah, like 2 copies, right?
Yeah, exactly, 2 copies,
With
right? Yeah,
one
sorry,
rep-
maybe
right,
my wording
yeah.
is wrong. Sorry, yeah, sorry,
Okay.
yes, exactly, two copies, right? So and you get 1 additional one for your analytics,
Okay.
right? So basically, you get 1 additional one, so it's 1/3 more that you get, and then basically, but you get basically the nice separation between the systems, right? So that you get that once, and then the operational system doesn't know anything about it or any load anymore about it, and you can just use it.
Okay, and the idea is still that the node that I'm projecting should actually have enough RAM to feed all that data sets there, right?
The data node, yes, right? The analytics engine in principle is built to be, well, to deal well or to degrade gracefully, right? If you don't have enough memory for this stuff. I mean, of course, I mean, if everything is memory, life is much better. But if it's not, things are degrading gracefully. So I think it's yeah, there's no cliff there in terms of.
Okay, so sorry about that many questions. Generally, if I understand correctly, Couchbase recommends for the original data service to be at least 25% memory resident.
Yes.
Will that same number applies to analytics as well?
I'm coming back to maybe answer that Marty gave in the full text section. You know, it depends on what your requirements are, right? I mean, basically the performance degrades reasonably linearly, right? And so what is an acceptable time for you, right?
Very good. Thank you. Thank you.
We keep trying. All right. I heard one in the back, then I'll come back up front.
Thank you.
Only one question on this.
Yeah, I just want to understand the internals of this analytics node.
Yes.
So is that just like simply copy the transaction data from that query database into the analytics, or it's actually doing some smart transformation there? So easier for you to analyze.
Yes. Right now it is exactly the same data that you're getting, and that is
just a separation of service. So
it's a separation of service. I mean, one of the real goals is to make sure that you have exactly the same data so that you basically can query everything, right? And then you can think about basically what do you do about storage, right? I mean, that's kind of probably what you're looking at. It's kind of how do you store that data, right? And that at the moment, basically, the way it works is
just
that
a replication.
Yes,
Okay.
it's the same structure. Yes.
Very good. All right. Back up front.
Actually, my question has been answered. I'll do a follow-up question on that. Looking forward on the roadmap, are you envisioning a new way to store, to persist that data, columnar perhaps, or anything along those lines?
It's certainly on the roadmap. I mean, the thing about it is columnar is really easy, right, if you have a schema.
Indeed.
And it's really not so easy if you don't have a schema. So basically, there's quite a bit of engineering involved in doing that, right? And so there are thoughts about that, and we have worked on that, but it's kind of, we're not there yet, right? So it's certainly an interesting topic, but yeah.
All right. Other questions there? Well, let me, this one I don't have to run so much. I'll take this one, and then I'll get you.
So we use a lot of Tableau and other analytics engines, BI. How do you see that beginning to play? How do you see that beginning to play into the new analytics service and improving integration with third-party tools?
Integration with third-party tools is of course important, right? I mean, there's an ecosystem around us, and I mean, Sachin in the back can tell you how far along.
Again, part of the product management team responsible for analytics. So to answer your question, I think we're going to be very opportunistic and customer-driven around it. We're not in the business of building data visualization tools, but we're working with a bunch of early adopters right now, and each of them, funnily enough, has a different tool that they're working with. So we're coming up with a way in which we can integrate with whatever is deployed in your customer premises, because our aim is not to cause any extensive change management to your existing processes. If anything, we want to reuse whatever infrastructure investments you have in your visualization tools and bring them to Couchbase as well.
Thank you. And over here.
Yes. Will you take advantage of multiple analytics servers running analytics services?
Yeah,
Because I heard you mention one. And
no, I just had one in the demo, but
right.
Absolutely. I mean, the whole point is many.
And I quickly ask a second question, sorry. What type of Amazon instance types do you recommend for the analytics service? I would think it wouldn't be the same as the one for data. So.
Well, again, it depends, right? I mean, the
experimenting
analytics service is very happy if you have a lot of memory, right? I mean, clearly, so if you have a lot of memory and then you might not care that much about disks, right? If you say, okay, I actually might want to not use that much memory, I want to use some more disk. I mean, there are the D2 instances, right, that Amazon has, which, have a lot of I/O bandwidth, right? And we do a reasonable job, I think, of reasoning about the fact that those are hard drives and that they have different read latencies. So I think those instances can be very beneficial as well. So,
Till, I had heard, and maybe I'm wrong, so I'll make the statement that the number of cores is as much as is important in the analytics nodes too. The more cores gives you that multiprocessing better.
Absolutely, yeah, that's, of course. I mean,
I think kind of.
Generic or more like a generic memory optimized or CPU optimized?
All right, let's go ahead.
Okay. So before I came to this conference, we actually tried a different approach of doing analytics, where we created a whole another cluster which only performs analytics. And so here we are adding it to the same cluster, but are you saying that it's the number of instances on data, like the data nodes versus analytic nodes are 1:1, or? Because we just created the whole thing all together. Even then, the instance type was not the same. So we had to drastically increase the instance type to even make sure that someone can perform analytics on that particular cluster. So
and so what the question is, what did you do in the cluster to get to that performance?
It took a lot of painful maintenances.
Yes. And do you create a lot of indices, I assume?
Yes.
Yes. And so that's kind of the point, right? I mean, that is if you think about the query service, right? I mean, it's optimized for quick lookups, index supported, right? And the thing is, the analytics cluster can I mean, there are indices in there, but you can also run it without an index and just rely on the scanning, right? In which case, that might be easier. But of course, I mean, with an index, things are faster. It depends on your query pattern. So I know that this is all very vague, but it's a very it's a pretty big piece of technology that has many use cases. So again, the number of configuration options didn't go down right now, right? So, but in general, I think probably you would be better off with the analytics nodes than with the other cluster.
Other questions? All right, I have a question.
Yes.
You ran a query before that told me which cities were going to have the most beer.
Yes.
And I didn't quite get the answer. I was sitting in the back, and that's really important to me. All right.
I have it on the slide somewhere, I think.
I do want to thank everybody for your time today, and thank you for the streamers who have been looking at what we've been doing. It's been a very busy day. Thank you, Till. I thought that was an excellent presentation. Give him a hand.
Thank you. And you maybe want to point at
Yeah,
the...
I definitely want to point to, hey, listen, this has been a great conference, hopefully so far. Hopefully you've also had the opportunity to go back into the general session and finish up. But make sure you are voting for us. This is how we get all the recognition that we can get, so we get more peers, more people using Couchbase, more people understanding it. Next year, I want to see 1,000 people at this conference, all right? Thank you.